All right. Hi, everybody. We finished chapter 2, and now we're going to start chapter 3. Chapter 3 deals with quadratic equations, quadratic functions, and inequalities. So now we're getting more into the realm of math. Section 1. This section seems pretty straightforward, but it has a lot of separate little rules that we have to go over. All right, so in section 1, we have what are called complex numbers. Complex numbers have this form. Where A and B are any integers or numbers, and I stands for imaginary. So in a complex number, you have a real number followed by an imaginary number. So similar, like we talked about earlier this semester about rational numbers. Every number can be represented as a fraction. 2 is the same thing as 2/1. It can be written as a fraction. So can real numbers. I mean, so can complex numbers. So, for example, 3 plus 5i is imaginary. 2 is an imaginary number because it's the same thing as 2 plus 0i. And negative 3i is a complex number because it can be written as 0 minus 3i. So every number can be written as a complex number. Yes. Sorry about that. So what are imaginary numbers? They cannot be graphed. You can't draw them on a graph anywhere. They're imaginary. It's needed because sometimes in mathematics, we'll get to a point where the rules stop, and now we have to proceed using another set of rules. We know the square root of 4. 4 is the same thing as 2 times 2. Since you have the same number written twice, it can be pulled outside, and so it equals 2. So 36. 36 can be written as 6 times 6. So since we have a pair of 6s, they come out. Or we can go one step further. 6 is written as 2 times 3 and 2 times 3. So we can pair up the numbers. 2 times 2, 3 times 3. Since 2 occurs twice, I can take it out. Since 3 occurs twice, I can take it out. So 2 times 3 equals 6. So you see it's the same answer. So whenever you have square roots, once you find 2 of the same type of number or letter or anything, you can take it outside the radical. It works the same thing with variables. So it's x times x times x. That's what x cubed means. Once we see 2 of a kind, that comes out in front. So that's what we end up with as our final answer. So in other words, we need to have 2 of the same type of numbers to pull it out and make it a perfect square root. What if that number is -4? What's the same number multiplied together that gives you a -4? It can't be -2 because -2 times -2 is a +4. So this is the problem that we're having when we deal with square roots. It works in cube roots. The cube root of -8 is 8 is made up of 2 times 2 times 2. So we have -2 times -2 times -2. We need 3 of a kind. That's what the root tells us. Once we have 3 of a kind, we could take it out. And there's our final answer. So the cube root of -8 is -2. But the problem with the square root of -4 is that there is no number multiplied to itself that equals 4. So that's why whenever we have a negative inside a square root, we take out that negative. We take out the negative and make it into an I. So now we have square root of 4 is 2. So that's the same. That's where imaginary numbers come from. So basically what you're saying here is the square root of -1 is I. That's the rule. That's the definition of what I is. It's a square root of -1. Because this is square root of -1 times 4. Square root of -1, square root of 4. The square root of -1 is I. Square root of 4 is 2. So the answer is 2i. So that's how you do it. If you ever have a negative inside an even root, whether it's a 2, 4, 6, 8, 10, whatever, as long as it's even, you cannot have a negative inside there. If it's odd, you can have a negative. All right, so that's what defines an imaginary number. We can talk about the algebra of complex numbers. When we say the algebra of complex numbers, we're talking about adding, subtracting, multiplying, and dividing. So if I had 2 sets of imaginary complex numbers, these are called binomials. They have 2 terms. 3 plus 5i. There's two terms. They're inside a parenthesis. So a parenthesis with two terms is a binomial. Let's look at how we add and subtract complex numbers. Steps. Remove the parentheses if possible. In other words, you have to be careful if it has in front of the parentheses, if it has a negative sign or if there's a coefficient. If there is, we have to distribute first. So if you have a negative sign or a coefficient on front of the parentheses, you have to distribute first to get rid of the parentheses. Then combine like terms. Call that CLT, combine like terms. So in the first parenthesis, there's nothing in front. So we just drop the parentheses. And there's nothing in front of the second. Well, actually there is. There's an invisible one. And it's positive, so it's not going to change anything. When we drop the parenthesis, we have these two signs next to each other. A positive times a negative becomes a negative. So if you have a plus sign in front of there, just write whatever's inside the parenthesis. Combine like terms. The like terms are you have the constant numbers and then the imaginary parts. 3 minus 2 is 1. Positive 5i minus 3i. 5 is bigger, so it's plus. 5 minus 3 is 2i, and there's your answer. Right, now we have coefficients and negative signs in front of the parenthesis. So first step, we remove parentheses. We can't do anything inside there, so we have to distribute. Remember, try to remember to keep your signs and your numbers separate. Negative times positive is a negative. 2 times 4 is 8. Negative times negative is a positive. 2 times 5 is 10. I. Negative times positive is a negative. There's a 1 there. 1 times 3 is 3. Negative times negative is a positive. 1 times 5 is 5i. Pretty much in mathematics, anytime you get rid of parentheses, the first thing you always want to do is combine like terms. So we have negative 8, negative 3, they're both negatives. 8 plus 3 is 11. Then you have positive 10i, positive 5i, they're both positive. So you add them, 10 plus 5 is 15i, and there's your final answer. Let's try it again. So it's positive 3, so positive times positive is a positive. 3 times 2 is 6. Positive is a positive. 3 times 3 is 9. I. Negative times negative is a positive. 5 times 2 is 10. Negative and negative is a positive. 5 times 3 is 15. Combine like terms. 6 and 10 are both positives, so there's 6 plus 10 is 16. 9i, 15i, they're both positive. 15 plus 9 is 24i. Right, so that's adding and subtracting complex numbers. Just combine like terms. Get rid of the parentheses, combine like terms. And it doesn't matter if there's a lot more of them, 4, 5, or 6 more, doesn't matter. You do the same thing. Get rid of the parentheses, combine like terms. Multiplication of complex numbers. Here's a rule. You cannot have an exponent on I. I cannot have an exponent. If it does, then simplify the term. Now, what does that mean? What does that next part here mean? Let's look. Okay, now we have coefficient. We've been practicing with these already. 2 times 3 is 6. Positive times negative is negative. 3 times 4 is 12. I. That's not a problem. There's no exponents or anything. But what if 3 had an I next to it? So we have positive is positive. 3 times 2 is 6. I. Positive times negative is a negative. 3 times 4 is 12. I times I is I squared. You cannot have an exponent. So what do we do with this number? I'm gonna give you the shortcut first, and then we're gonna prove what it is. Whenever you have an I squared, remember, we know that I is the same thing as square root of -1. If you square both sides, the square root and the square cancel, so you get -1. So if you have I squared, replace it with a -1. Negative times negative is a positive. 12 times 1 is 12. So basically, all an I squared does is change the sign in front of the coefficient. Change the sign and get rid of the I. That's what an I squared does. But later on, we're going to do something like this. What is that going to equal to? That's what we'll do later. But for right now, whenever you see an I squared, it becomes -1. Basically, you just change the coefficient of the sign of the coefficient in front of it. Work this one out. Negative 4i times 2 minus 3i plus 5 times negative 3 minus I. Look at the signs first. Negative times positive is a negative. 4 times 2 is 8i. Negative times negative is a positive. 4 times 3 is 12. I times I is I squared. Positive times negative is a negative. 5 times 3 is 15. Positive times negative is a negative. 5 times 1i is 5i. We have an exponent here. Remember, I squared is the same thing as -1. So basically, all it does is change the sign of the coefficient in front of it. So from positive to negative, 12. Bring everything else down. So this is what happens. All it does is change the sign and drops the I squared. So negative 12 minus 15, they're both negative. 12 plus 15 is 27. Negative 8, negative 5i, they're both negatives. 8 plus 5 is 13i. And there we have it. All right, so the only thing that we're introduced to this next section here is with the I squared. Let's do some more. But so far, we've just been multiplying by single terms. Two plus 3i, 5 plus 4i. Whenever you multiply two binomials, remember it's a binomial because it has two terms inside there. Use the FOIL technique. FOIL is an acronym. First. So we multiply the first terms. 2 times positive and positive is positive. 2 times 5 is 10. That's the first. Outer. Positive times positive. These are the outer ones. 2 times 4 is 8i. The inner ones, the two close to each other, they're both positive. 3 times 5 is 15i. And the last terms, the 3i and the 4i. They're both positive. 3 times 4 is 12. I times I is I squared. So the first parts, those are the real numbers. The last parts are the imaginary numbers. And the outer and inner, that's a mix. The outer ones and inner ones. So we just, this is inner and this is last. First, outer, inner, last. So this is the, do this first, do the second, do that third, and do that fourth. All right, then order of operations, exponents, I squared. Remember, I squared is the same thing as -1. So all it does is change the sign of the coefficient. So it becomes a -12. You drop I squared and just change the sign in front of it. Combine like terms. 10 positive and negative. 12 is bigger, so it's negative. 12 minus 10 is 2. 8 and 15, they're both positive. 8 plus 15 is 23. And there's your answer. So that's how you multiply complex numbers. Dividing complex numbers. As long as the denominator does not equal 0, you're doing good. So the rule here is you cannot have i's in the denominator. You cannot have i's in the denominator. So we have to get rid of it. So the first one to look at is if your denominator is only a monomial, a single term. Or binomial, it had 2 terms. So this has only 1 term in it. If you have imaginary on the bottom, and it's a monomial, then you have to multiply the top and bottom by I. Because I over I is the same thing as 1. So you're changing the number the way it looks, not the number. So anything multiplied by 1 is itself. So 2 times I is 2I. I times I is I squared. Remember, you cannot have an exponent in a imaginary term. So that changes the sign of the coefficient. And the final answer here is -2I over 3, because you can't have negatives on the bottom. Okay, work that one out. -6 over 7I. Remember, we can't have an I on the bottom. So multiply top and bottom. Since it's a monomial on the bottom, we just multiply top and bottom by I. -6. Negative times positive is negative. 6 times 1 is 6. I. Positive is positive. 6 times 1 is 7 times 1 is 7. I times I is I squared. You can't have an exponent on I, so this becomes a -7. The negatives cancel, so you have 6I over 7. Pretty straightforward. How about if I had 5I over 7I? Should be finished already. What did you do? Why not? I mean, that's what we're going over. The rule is what? You cannot have I's on the bottom. If there's an I on the bottom, what do? Multiply top and bottom by I. That's what we've been doing the last 3 examples. If you have an I on the bottom, then multiply top and bottom by I. Because this I over I is 1. But before you do anything, you can cancel things that are the same first. So the I's can cancel. The answer is 5 over 7. And if I lose you, don't just sit there. It's the worst thing ever you could do, because if I lose you one place and I keep on going, you just wasted the entire day. It's not why even show up then. If I lose you someplace, that's when you have to ask questions. Where did you get that? What did you do? How'd you get that? So just sitting there, expect me. I would have never known if you didn't know what we're doing unless I asked you. So please don't just sit there like a log. Talk. So in here, you could have multiplied I's, but I and I, we've gotten 5I squared, 7I squared. Change the signs. Negatives cancel. You get the same thing, but a lot of extra work. If you have whatever you have to say on top and bottom, cancel and get rid of that. Right. Yes, correct. If one of them is squared, you have to do that order of operation. You have to do the exponents first. Okay, how about this one? 3 plus 5I over 2I. What's my first step? Yeah, multiply top and bottom by I, because the bottom is a monomial. And we cannot cancel these I's. because this on top, since it has a plus or minus, that is one number that has to stick together. The i's cannot cancel. So we have to multiply I divided by I. Whenever you have a monomial, I over I. Distribute. So we have positive times positive. 3 times 1 is 3i. Positive times positive is a positive. 5 times 1 is 5. I times I is I squared. 2 times 1 is 2. I times I is I squared. We have two terms with exponents in them. So all they do is change the sign of the coefficient. So it's 3i minus 5 over negative 2. Yeah, I squared, drop the I squared and change its coefficient. Drop the I squared, change the coefficient sign. This negative goes on top. So I distribute in there. Negative 3i, negative and negative makes it a positive 5. This is, even though the answer is correct, this is not written correctly. Because remember, imaginary terms or complex numbers have this form, a plus bi. So we have to move them around. So we have the real number first and then the imaginary. So parts are good. That's the easy part. That's if you have a monomial. What else can we have on the bottom? A binomial. Since the bottom is a binomial now, these are now with binomials on the bottom. This was not as simple as the other one. When you have a binomial, in the denominator, you must multiply both the top and bottom by the conjugate of the denominator. The bottom number. When you have a binomial in the denominator on the bottom, you must multiply both the top and the bottom by the conjugate of the denominator. So what exactly is a conjugate? The conjugate All you have to do to get the conjugate is change the sign of the I term. The imaginary term. To find the conjugate, you simply change the sign of the imaginary term. See what this means. So the conjugate here would be what? With what I just wrote here. No, what did I tell you to do in front of the I term? Yeah. 4 minus 5i. Whatever the bottom is, whatever the sign of in front of the I, change it. That's the conjugate. Just what was for that. And I'll show you, we'll do a bunch of examples in a second. Let's work this one out then. On top, we have 3 times 4 is 12. Positive times negative is negative. 3 times 5i is 15i. On the bottom, positive times positive. 4 times 4 is 16. Positive times negative is negative. 4 times 5 is 20i. So that's done. That's all for the first term. Now we got to multiply the second term to everybody on the other equation. Positive times positive is positive. 4 times 5 is 20i. Positive times negative is negative. 5 times 5 is 25. I times I is I squared. We're going to do a bunch of these in a second. So if you're not catching that, don't worry about it. We'll get you caught up there. Basically, we just take everything from the first parenthesis and multiply it to everything in the second. Combine like terms. Negative 20i and 20i cancel. I squared changes the sign in front of its coefficient. So we have 12 minus 15i over 16 plus 25. Over 41. And of course, since 41 is a prime number, we can't go any further. But if that was a 21 instead, we had 12 minus 15i over 21. We have to simplify. What do the top and the bottom numbers have in common? A 3. So on the very top, if we factor out a 3, 12 divided by 3 is 4. 15 divided by 3 is 5. And then 3 times 7 on the bottom. So this would be your final answer. If you could simplify, you have to simplify. So in our case, since 41 is a prime number, we can't go any further. But if it was factorable, then we'd look for what they have in common. Okay, let's look at more of these conjugates. I'm gonna get you to a point where you can just look at it and tell me what the answer is gonna be with a conjugate. Okay, so what's the conjugate of this one? What's 3 plus 4i? Because to get the conjugate, you simply change the sign of the number in front of the I. Okay, work it out. Multiply out. So every term inside this first parenthesis has to multiply to every term in the second. 3 times 3 is 9. Positive times positive is a positive. 3 times 4 is 12. I. Negative times positive is a negative. 4 times 3 is 12. I. Negative times positive is a negative. 4 times 4 is 16. I times I is I squared. Middle, they're same numbers, different signs. The I squared changes the sign in front of its coefficient, so it's plus 16. This answer is going to be 13. What's the conjugate of this next one?
Is it positive 2 minus 3i?
Almost. Only change the sign in front of the 3 and it's in front of the I. Leave the constant term alone. Good guess though. Yeah, so you leave that negative 2 alone, only change the sign in front of the I. So we have negative times negative is a positive. 2 times 2 is 4. Negative times negative is a positive. 2 times 3 is 6. I. Next one. Positive times negative is a negative. 3 times 2 is 6. I. Positive times negative is a negative. 3 times 3 is 9. I times I is I squared. The middle terms cancel. I squared changes the sign of the coefficient.
Four plus 5i.
Very good. Yes. 4 plus 5i. So we get 4, they're both positive. 4 times 4 is 16. Positive times positive is positive. 4 times 5 is 20. Those are the first two. Now the second ones. Negative times positive is negative. 5 times 4 is 20. I. Negative times positive is negative. 5 times 5 is 25. I squared. We know in the right track because middle terms cancel. The I squared changes the sign, so it becomes. And then equals 41. Okay, we'll do one more. See if we get the shortcut.
-7 minus 2i.
Yes, excellent. Negative is a positive. 7 times 7 is 49. Negative times negative is positive. 7 times 2 is 14. I. Positive times negative is negative. 2 times 7 is 14. I. Positive times negative is negative. 2 times 2 is 4. I times I is I squared. And the I squared changes that to a plus. Well, I'm gonna show you short. Yeah, you're very close to yes. How about this? This, to be honest with you, when it comes to conjugate, this one gives people more trouble than anything.
Would that be 1 minus I?
Yes. Yes. But now you got to work it out. This is what we have. 1 times 1 is 1. 1 times negative I is negative I. Positive times positive is positive. 1 times I is I. Positive times negative is negative. I times I is I squared. The middle terms cancel. What number is in front of the I squared? There's a 1. So this I squared changes the sign. So it becomes 1 plus 1, which is 2. Yeah, that's the most common mistake. People put 1 as the final answer because the I squared. Because remember, whenever you see I squared, that's the same thing as -1. So right here, we had I squared is -1. So negative of negative makes it a positive 1. Now, here's a shortcut. You notice in the steps, the middle terms always cancel. So that means all we're left with are the outer terms. 3 times 3 is 9. 4i times 4i is 16i squared. It's always this case. When the I squared kicks in, always makes it a positive. So it's the square of the first term plus the square of the second term. 3 squared is 9. 4 squared is 16. Add them together, you get 25. Square of the first one is 2 squared plus 3 squared. 2 squared is 4 plus 9 is 13. 4 squared is 16 5 squared is 25. Add them together, you get 41. 7 squared is 49. 2 squared is 4. 49 plus 4 is 53. 1 squared plus 1 squared is 2. So that's a shortcut whenever you multiply conjugates. The middle terms always cancel. The last term always becomes positive now. And it's just square the two numbers and add them together. There. Now we have binomial divided by a binomial. Remember, these are single numbers. They have to stay together. So what do we multiply these guys by?
The first one, 3 minus 4
Times what? What do we
I.
multiply? No, because whenever you multiply by, it's always the conjugate of the bottom.
Oh, okay.
So it's always going to be whatever the bottom is, the conjugate of it. Because it has to be the same number because you're multiplying by 1. Can you tell me what the bottom number is going to be just by looking at it? Using the shortcut method? Very good, 29. 5 squared is 25. 2 squared is 4. 25 plus 4 is 29. That only works on the bottom. The top part, we have to work it out. Three times 5 is 15. Positive times positive is a positive. 3 times 2 is 6. Positive times positive is a positive. 4 times 5 is 20. I. Positive, positive. 4 times 2 is 8. I times I is I squared. So I have 15. We can combine the two middle terms. 20, they're both positive. 20 plus 6 is 26. I. The I squared changes the sign of the coefficient, so it's minus 8. -15 8 is 7. Plus 26i over 29. Since 29 is a prime number, can't go any further. Do another one. All right, let's do another one. Eight minus 5i divided by 9 minus I.
So for the first one, is it 81 minus I? Or
Well, you know, first of all, what do you multiply by?
Oh, 9 minus I.
Plus I.
Oh,
Because it
plus.
has to have this, it has to be the same numbers. It's just that they have to have different signs.
Okay.
So what's the bottom gonna be?
81. Oh, 82.
Because 9 squared, there's a 1 here, so it's 1 squared.
Mhm.
81 plus 1 is 82. 82. Negative times positive is a negative. 8 times 9 is 72. Positive times positive is a positive. 9 times 5 is 45. Negative times positive is a negative. 8 times 1i is 8i. Positive times positive. 5 times 1 is 5. I times I is I squared. Negative 72. Combine the middle terms, they're both i's. So 45 minus 8 is 37i. The I squared changes that plus to a minus, so it's minus 5. They're both negative, so it's 72 plus 5 is 77. Plus 37i over 82. And nothing can simplify. So that's your final answer. Get better? The hardest part is the multiplication part and the adding. That's like, I'm not gonna lie to you. Most mistake happens in the adding and subtracting parts. Okay, the next part. Remember I said earlier is you cannot have an exponent on I. But what if it's a big exponent? There's a whole process. We have to figure out a pattern first. Let's look at a pattern first. What do we know so far? We know that we begin with I. Remember, I is equal to the square root of -1. And if we square both sides, so I squared is the same thing as -1. So what's I to the third going to be? Well, let's see. What is I third made up of? With what we know so far, it's made up of I squared times I. There are 3 i's. What's I squared? -1. -1 times I is -I. So I cubed is the same thing as -I. I squared is the same thing as -1, and I is itself. What's I to the fourth? Well, I to the fourth is I to the third times I. I to the third is negative I times I. So that's negative I squared. But what is I squared? I squared is negative 1. Negative, negative makes it a 1. All right, let's do a couple more of these. I to the fifth. I to the fifth is same thing as I to the fourth times I. I to the fourth, we just figured out was 1. 1 times I is I. Does everybody see what I'm doing here? I'm building up a library so I can see what the patterns are. I to the sixth is I to the fifth times I. Well, I to the fifth, we just calculated was I. So I times I is I squared. Well, up here we learned I squared is negative 1. I to the 7 is I to the 6 times I. I to the 6 was negative 1. Negative 1 times I is negative I. Let's do one more. I to the 8th is I to the 7th times I. I to the 7th was negative I times I, which is negative I squared. Well, I squared from up here, we know it's negative 1. So it's negative of a negative 1 makes it a positive 1. I have it, I see a pattern. Yeah, but in a specific pattern. So we have this pattern. I to the 4th was 1. I to the 5th was I to the 6th was negative 1. I to the 7th was negative I to the 8th was 1. So I is equal to I. So we see that they repeat themselves in groups of 4. They repeat themselves in groups of 4. And it's always this pattern. It's like, it's easy to remember is if you win a race, what would you yell out? I won, I won. I won, I won. And the middle two are negative. So that's the easy way to memorize it. But now we got to figure out what is the pattern when we do these things. So I to the power of 45. The steps are this way. First step. Divide the exponent by 4. Why by 4? Yeah, because our groups are in groups of 4. They start repeating themselves after the 4th one. Okay, so in our case, we have 4 goes into 45. 4 goes into 4 once. 4 goes into 5 once. We want the remainder. Look at the remainder. That number there. If the remainder is 1, 2, 3, or 0, the term becomes I1, the middle two are negative. So since our remainder was 1 on this I to the 45, our answer becomes I. Let's try another one. I to the 173. Okay. Yeah, it goes I1. So 1, 2, 3, 0. So whatever your exponent is of I divided by 4. 4 goes into 17 how many times? 4. 4 times 4 is 16. Subtract them. How many times 4 go into 13? 3. 4 times 3 is 12. Subtract them. Here's our remainder. So this one becomes what? I. I to the power 67. 4 goes 6 once. 4 goes into 27 how many times? 6. 6 times 4 is 24. The remainder is 3. 1, 2, yep. Answer is negative I. So far, so good. Did we talk this, did we finish up the transformations last time? Did we do all the transformations? I think so, okay. Let's move on with this one then. Look at quadratic equations. And functions. This is section 3.2. What exactly is a quadratic equation? A quadratic equation has this form. AX squared plus BX plus C equals 0. Because an equation, yet you're solving for something, you're setting it equal to 0. This is called the standard form. Of a quadratic equation. So whenever you solve quadratic equations, you gotta set it equal to 0 before you do anything. Then the quadratic function looks like this. So whenever you're solving them, you have to set it equal to 0, put it in the equation. But everything else, if I give you a function and I define a variable, for example, I say f of x equals 2x squared minus 3x plus 5. Here's a quadratic function. Tell me what answer that is. What is that telling you to do? Plug in 2 anywhere you see an x, exactly, yes. So anywhere I see an x, I plug in a 2. Two squared is 4. Two times 4 is 8. Negative times positive is negative. 3 times 2 is 6. Eight minus 6 is 2. Plus 5 is 7. So what does this stuff tell us? What is it giving me? If I give you this, if I said this, what does it mean? Okay, what does it mean on our graph? The X and Y components, exactly. It tells me the location of a point on the graph, on the curve somewhere. To solve quadratic equations, we have numerous methods. The first one is by graphing. The second is by a process called factoring. Third method is completing the square. And the last method so far is the quadratic formula. Of these four, we're not going to do the graphing one, because to do the graphing one, you got to plot a whole bunch of points. And since quadratic equations are not straight lines, it matters what numbers you pick. So, and also the answers could be in decimals. Very imprecise in graphing. So the other parts will be factoring. If it's factorable, not all equations are factorable. You can take one equation and break it down into smaller binomials. That's factoring. Completing the square is a process. It'll always work, but it requires you doing a lot of math. And so a lot of times it could involve using fractions. The safest way that always works is the quadratic formula, and we'll get to that next week. But we have to first build up to it. All right, before moving on to this part, I want to discuss the library of functions and what it means. The library of functions will define the basic functions that we're going to deal with and what they're supposed to look like and what they can tell us. All right, let's start with this. The first one is called a constant function. In other words, your equation is just one number. Let's say like 3. No variables involved. The constant function, let's say equals some value c. Because it doesn't matter what it is, it's always going to be a horizontal line through that number. If it's positive, it's on above the x, it's negative below. It'll be a horizontal line. The constant function is a horizontal line. The next one's called a linear function. This equation is a straight line with a slope. The next one is a quadratic function. The next one's called a cubic function. Then we have a radical function. Squared. Radical function cubed. These two graphs are pretty similar, except for one major point. What's the rule? What can you not have inside a square root? You cannot have a negative. Can you have a zero? Square root of zero is zero. It just can't be negative. So what this graph looks like is like this. It starts at 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. The main difference between the square and the cube root is just that it can be negative inside the cube root function. So those are two radical functions. If the root is odd, that's called a root there, you can have a positive and negative. If the root is even, you can only have positives. Now, a rational function. Rational means a fraction. This time the x is on the bottom. Whenever x is on the bottom, we have what are called asymptotes. Because we know that x cannot equal 0, because you cannot have zeros on the bottom. So that's my asymptote. X cannot equal 0. It's my limitation. Also, since there's no x on top, the function cannot equal 0. So there's another asymptote. The bigger x becomes, the smaller this number becomes. So it looks like this. The closer it gets to 0, the bigger the number gets. Or the bigger the number gets, the lower it gets to 0. And I'll use negatives as well. If X is negative, Y is gonna be negative. If X is positive, Y is gonna be positive. A rational function squared. Now, this is if X is on the bottom and X, or the equation of X is squared. Again, we still have asymptotes because you cannot have 0 on the bottom. When you square a number, it becomes positive. So with this answer, we cannot have negative answers. But we can use negative X's. If we use negative X's, the answer is going to be positive. It looks kind of like the Atari symbol. The absolute value equation or function. The only thing we know about absolute values is it can never equal some 0. You can put positive and negative inside there and 0, it'll always be positive. So it would look something like this. And then the greatest integer function. You can see it one of the two ways. You can see it with these brackets with these big bars in the middle, or you can see it with INT(x), integer X. What this one says is you don't have any decimals. There are no decimals here. So if the X is 0.0, it's 0. If it's 0 point everything all the way up to 1, it stays at 0. So you just drop off the decimals and leave it as a solid number. So what you're really doing is you're rounding to the left. It's called the stair step function because it looks like a bunch of stairs. And then the last two we'll talk about later in chapter 6. The exponential and logarithmic functions. So we'll talk about those in chapter 6. As we start building these equations, as we go on to this chapter, and then in chapter 4, we're gonna be able to define any one of these functions and their graphs and their intercepts, the range, domains, any asymptotes, horizontal or vertical, but we have to know what they look like. Quadratic functions. When we say solutions, when you say find the solution, what is the solution of this function? What we're really talking about are the x-intercepts. They're also called the roots and the factors. All of these words mean the same thing. So if I ask you, what are the roots of this function? You're actually finding these solutions, the x-intercepts. How do we find x-intercepts? Remember from chapter 1? How do we find x-intercepts? Very good. Set y equal to 0 and solve for x. Very good. And those are what we call solutions. The degree of an equation tells us the maximum number of solutions possible. The degree of an equation tells us the maximum number of solutions possible. So if we look at a quadratic equation, the degree is the exponent, the highest exponent. The degree here is 2, which means I can have at most 2 solutions. I can have 2 solutions this way. I could have only 1 solution. Or I can have no real solutions. What is a leading term? What do you think leading term means? It's the, yeah, it's the first one of the equation, right? For example, if I had this quadratic equation, my leading term is the term that has the degree in it, the highest exponent. That's the leading term. So what does the leading term tell us? Is what? In the leading term, we have the degree. Number of possible solutions. What else? It can also tell us the number of vertices possible by n minus 1, where n is the degree. So what's a vertex? You've heard that word before. What's a vertex? What do you mean endpoint? It's not, okay. Yes. Yeah, it's the highest or the lowest point. That's the vertex. On a curve. You can't say endpoint because the graph goes on infinitely. So the vertex, the vertices are the lowest or the highest. How do we know if we have a okay, so notice lowest and highest points. We either have a maximum or a minimum. When do you have a maximum? If what happens? Is this a maximum or minimum? Minimum means the smallest. So that's the minimum. The maximum is the highest. The maximum is the highest number possible. So you have a maximum, the highest point, and you know you have that if A is negative. What is A? Yeah, A is the leading coefficient. A is the leading coefficient. It's the number in front of the x squared. If it's negative, it points, the graph points down. Then we have a maximum. If A is positive, then it opens up and we have a minimum. And you notice, because the degree is 2, 2 minus 1 gives us 1. We only have one vertex. If we had a cubic equation, something like this. What does this tell us? We have 3 solutions, so we can cross the graph at most 3 times. So 3 minus 1 is 2. That's the number of vertices. 1, 2. We'll have 3 solutions, 2 vertices. Since the coefficient is 1 and it's greater than 0, we know that it goes down to the left and up to the right. Remember, n is your degree. And this is the leading coefficient. So if your leading coefficient is positive and the degree is even, what's the graph going to look like? If the n is even, if the degree is even, 2, 4, 6, 12, 24, and the leading coefficient is positive, what does that tell us the graph's going to look like? Both ends will be facing up. What happens in the middle, we don't know. It could be a bunch of ups and downs, but we know that both ends point the same direction, up. This is what we call end behavior. If n is even, that means both, if it's even, they point the same direction. Up if it's positive, down if it's negative. If the leading coefficient is negative. If n is odd, the ends point in opposite directions. If the leading coefficient, if a is positive, that means the negatives go to negatives and the positives go to positives. And if a is negative, then it switches. The negatives go to positive and the positives go to negatives. Knowing this, we will at least have a basic idea what the graph's going to look like. How many intercepts we're going to have, how many vertices we can have. What happens on the end behaviors. Ooh, not only we only got 20 minutes left. And if I start this thing here, we won't finish. Because now we're gonna start dealing with the calculations and everything like that. Okay. Let me see, should we do this? What do y'all think? Do today or next week?
However you would like.
Well, see, the thing about it is, I don't want to keep you guys too late, because if I start it, just the examples alone are gonna take almost an hour. Let me see. Because this next section is we have to put everything together for quadratic equations. How to calculate the vertex, how to calculate the x-intercepts, how to factor, how to complete the square. Actually, let's look at the vertices first. We'll end here. Finding the vertex of a quadratic equation. Because it has to, in order to do anything, you have to set it equal to 0. And I'll give you the formula for it. The vertex is a point. It's a point, which means it has an X and a Y component. The X component, here's the formula for it. Where B and A are those parts, the code numbers in your equation. And the Y component of your vertex is once you find this value here, plug it back into the equation and work it out, and that'll find you your vertex. Because this is one method. The next method I have to use complete the square, and I'll show you that when I get to it. So we have this formula here. Let's look at an example. Y equals 2x squared minus 8x plus 3. Find the vertex. Then tell me the direction. Tell me the y-intercept. And the vertex. Next time we're going to do the x-intercepts and everything else. What can you tell me about the direction? It's even. Well, what's even? Well, yeah, it doesn't matter if it's even or not. This happens, okay, this is even, which tells us that it's a parabola. It's a quadratic equation. Because it's 2. Which means both ends point the same direction. Since this number here, the 2 in front is an positive number. Since this is greater than 0, it opens up. We know our graph will look like this. What's my y-intercept? Y-intercept is always the constant. Because the way you find the y-intercept is you set x equal to 0, whatever's left is your y-intercept. So let's
So
label
do
these.
you always put 0 in front and
Yes,
then
because
the
the
y?
y-intercept is a point. To find the y-intercept, you set x equal to 0 and solve for y.
Okay.
So let's label A, B. What's A? It's 2, that's leading. What's B? -8, very good. And C? Yeah, so whatever's in front of the X is your B. Whatever's in front of your X squared is your A. And whatever the constant is your C. And for the vertex, here's our formula. So negative, what's B? Is -8. 2 times A. Negative makes it a positive. 2 times 2 is 4. Eight divided by 4 is 2. So that's how you find the X value of the vertex. What do you do with this number now? Yeah, now we plug it inside the function. Anywhere we see an X, we put a 2 in its place. Two squared is 4. Two times 4 is 8. Negative, positive, negative. 8 times 2 is 16. 16 is bigger. 16 minus 8 is 8. -8 plus 3. 8's bigger, so it's negative. 8 minus 3 is 5. So that's where our vertex is. It's not difficult, it's just lots of steps. Well, we're lucky that it was a solid number. If it was a fraction, then we'd have more problems up here. But each one of these methods I'm going to show you have their pros and cons. This fractions would be a con for this one. So our vertex is 2, -5. Another thing we can say is called the axis of symmetry. Since we know our graph has a vertex at 2, 5, and it opens up and has a y-intercept at 3. I know these 3 points already. The vertex is at 2, -5. That's the vertex. My y-intercept is at 3. Where did this point come from? Exactly. Because since this is my vertex, if I folded the piece of paper along this line here, this side would fold over here and it'd be mirror images. So it's 2 to the left, up 2, or up 3. So it's 2 to the right, up 3. Has to be a mirror image. The line that you fold on is called the axis of symmetry. It's simply the X value of the vertex. The axis of symmetry is equal to the X value of the vertex. So you can simply say negative b over 2a. That's going to be the axis, or x equals negative b over 2a. So we're slowly piecing our numbers to our graphs together. If you notice also, look at these y-intercepts or x-intercepts. Those are going to be pretty hard to find, which is why we need so many different methods. And that's what we're going to do next time, is we're going to find these x-intercepts. So today we talked about direction, x-intercepts, y-intercepts, the vertices, axis symmetry, library of functions, and what they mean. Okay. From this equation, what is the maximum number of solutions I can have? And what is the maximum number of vertices I can have? Maximum I can have 5, because that's what
5.
the degree is. So how many vertices can I have?
5.
It's always going to be the degree minus 1.
Okay.
Because think about it. If our equation was x squared, that means we can have 2 x-intercepts, right? 1, 2, which means we can only have 1 vertex. Now, when it says, what's the minimum number of solutions we can have? If the degree is 5, maximum is 5, what's the minimum?
2,
Why 2?
because it's the smallest number on the.
Nope. Actually,
No.
once we look at an equation, this part here tells us everything that we would know about, except for the y-intercept. Everything else is just fluff. This tells us everything we need to know. The minimum is 1. Because Since it's an odd, we know both ends point different directions. 1, 2, 3, 4, 5. One, two, three, 4. One, two, 3. One, 2. 1. So the smallest, it has to have at least 1. If the exponent, if the degree is odd, since they point different directions, you have to have at least 1. So from 1 to n, number of solutions. If n is odd. Remember, n is the degree. And if x is even, so if n is even, we can have 1, 2, 3, 4, 4 solutions. 1, 2, 3 solutions. 2 solutions. 1 solution, or no solutions. So we can go all the way from 0 to n number of solutions if n is even. Because if they point the same direction, I can move them either above or below the x-axis and never touch it. But if it's odd, degree is odd, then it has to point through the line at one point. All right, we'll pick up from here next time. And next time, we're gonna do a lot of calculations. We're jumping straight in doing a bunch of calculations because we're gonna learn all 3 methods of solving quadratic equations. And then we're gonna start building up from there. Okay, go enjoy the sunshine, beautiful weather. And
Thank you. Have a great day.
you too, thank you.